Okay, I might do more factoring because I think when we get back factoring, like I don't think graphing quadratics is on your final, but I mean to me it's not that bad. I'll try to explain it in the notes. Okay, step one is the vertex is always the opposite of whatever's with x, and then y is the same. Step one. A is 1. So what that means is we do the good old x, so movement chart. Plus minus 1 of the vertex, I go up 1. Okay, if I go left or right 2 of the vertex, I go 2 squared is 4, I go up 4. If I go plus or minus 3, 3 squared, the y distance is 9. We're at negative 8, we'd go up to 1. It's 3 away. If you go plus or minus 4, you go up 16. We're at negative 8, we jump all the way up to 8. 1, 2, 3, 4. 1, 2, 3, 4. Perfect quadratic. Okay, this one's a little bit harder. Vertex is still the same. Opposite of whatever's with x. Okay, this movement chart's a little different. We got x squared, and we got negative 1 times x squared. This is technically our y. Axis of symmetry. If I go plus or minus 1, I'd normally go up 1, but what's negative 1 times 1? I'd go down 1. Okay, if I go plus minus 2, I'd normally go up 4, but that negative 1 in front of the x squared, they call that a. And it's not really, I don't want to give you another a, okay, but it's basically whatever's in front of that is what you multiply the x squared by. If you want me to go on a tangent, if I do x minus 5 squared, I get x squared minus 10x plus 25. It's a perfect square trinomial. So, see, when I distribute that, I get a negative 1x squared. So that's why we're doing this extra chart. One, two, three. It reflects it. If I go left 2, down 4. Okay. If I go plus or minus 3 of the vertex, I normally go up 9, but multiply it by negative 1, I go down 9. If I go plus or minus 4, normally I'd go up 16, but I gotta go down 16. So that'd put me at negative 8. You guys will fast forward it while I try to find my orange highlighter. Okay, this time, what's sitting in front of the x squared term? 2. So when you make your movement chart, let's see if I have enough space to make it here. X, x squared. Now, there's a 2 in front of the x squared term, because again, it'd be 2x squared plus 6x plus 9. Like if I did x plus 3 squared. I know the shortcut. See, I get that 2x squared. So this is going to be our y this time. This is how far you travel on the y. Okay, what's that vertex? I made these myself. So I started at the very bottom. Okay, if I go plus or minus 1 of the vertex, I'd normally go up 1. But I've got to multiply it by 2 because that's our y distance. So normally I'd go up 1, but I have to do 2 times 1, so I got to go up 2. So if I go left or right 1 of the vertex, I go up 2. All right, if I go left or right 2, 2 squared is 4. Well, we're doubling that. 2 times 4 is 8. So we're at negative 10. So that would put us up at negative 2, because that's 8. It's doing what we call vertical stretch. It's like we're taking, it's doing vertical stretch. We're taking the vertical axis and stretching it. Boy, I need to clip my fingernails. Okay, moving on. Normally I go up 9. This time I got to double that. So I'm at 10. I'm at negative 10, so if I go up to 8, that's got it. And they also call it a horizontal shrink. It's like we're taking the horizontal axis and they used to be called a compression. Okay, vertex, step 1. Okay, see if you can set up the vertex movement chart yourself. So there, that was 1 there. I had to make an extra column. What's negative 1x squared? I had to make an extra column. Pause it and see if you can make it. Okay, this is the y distance. If you do negative 3 times whatever x squared is. So if I go left or right 1, I'm going to go down 3. So it's like stretching the vertical axis a lot. So I'm at 10. So if I go right 2 of the vertex, I drop 12. So those are really the only. So if I'm at 2, if I'm at 10 and I go down 12, that puts me at negative 2. And those are really the only ones that's 2 away from the axis of symmetry. It looks like a V, but it's really got a parabolic shape. So like stretched it, reflected it, the parent function. Okay, so see if you can find the vertex and make the vertex movement chart for this one. It's all about what's in front of that x squared term. And again, this is negative 3 times x squared plus 2x plus 1. So you can see that's why you got to do negative 3x. And this is 4x plus x squared plus 2x plus 1. So we're multiplying the x term technically by 4. So see if you can do this one by yourself. There's the vertex movement chart. If I go left or right 1 of the vertex, I got to go up 4. So I'm at negative 10, that put me at negative 6. Mirror it. Okay, if I go right 2, I got to go up 16. So I'm at negative 10. That put me at 6. This was this is on the notes from last week. Okay, vertex in this one, it's 0, -4. And the number in front of 1, okay, so the vertex movement chart is just going to be our normal one. The x squared is the y distance. If it's plus or minus 2, you square it. So we're just using the good old normal one. If I go left or right 1, I go up 1. If I go right 2, I got to go up 4, which would put me at an x-intercept. Mirror it. If you go right 3, got to go up 9. So I'm at -4. So if I go up 9, that's 5. And then that's 3 this way. Okay, this is the bottom part. This is kind of like on your, this is on your final. So it says write an inequality and use it to solve the problems. You're selling concession stands at a football game. You sell bags of popcorn for $2.50. I just made this up. It's a true story I made up just to get a problem done. And nachos, that seems like a big seller at the football games here. So we have 2 unknowns. Okay, as a student, where kids really struggle with these problems, to me, I've been teaching a really long time. I'm trying to find my green highlighter. Found it. Okay, so you want to make at least $300. Okay, so you got to know which inequality to use. The least amount you want to make is 300. Let X be the number of bags of popcorn. So it's telling us what the variable is, and Y is nachos. And it's telling us 52 bags of popcorn. So once we write it, we're trying to find X, or we're trying to find Y. That's X. How many nachos? Orders of nachos. Okay. So step 1, write the problem. 2.5x because it's $2.50 per bag of popcorn, plus $5 for each nacho. At least means you want to make. I did it wrong. 1 second. Let me find my. Pause it. Okay, I'm back. I messed up. We want to make at least $300. So it's greater than or equal to 300. That's the inequality. Okay, now that's part 1. Okay, here's part 2. Okay, it's saying okay, it's telling us 52 bags of popcorn. I'm running out of space. All right. 2.5 times 52. Let's see. Can I do this in my head? 104. Okay. It's 542. I'm going to use a calculator. So you made $130 from popcorn, $5 for nachos. Get Y by itself. 170 divided by 5. I don't need a calculator. 5, 10, 15, 3, 36. So you're going to make 36 orders. Thank you. So it'd be 36 orders of nachos. As a salesperson, this is not true. This is not a good example, but I found it online. As a person, Cecil is paid $60 per week plus $6 per sale. The week Cecil wants to make at least 130. Let X represent the number of sales. So X is sales. Okay. He wants to make at least $130. So he wants to make 130 or more. So how many sales does he have to make? Well, we do 60 per week plus 6 per sale. And you want to make at least 130. I wanted to pick one where you had to round. How many times does 6 go into 70? It's 11. 11 2/3. For sure. Let's try it. Yeah. Okay. So if you did 11 cells, you'd only make 6 times 11, 66 plus 60. You'd only make 126. So there's some rounding that need to make 12 cells to meet goal. At least. Okay. Another video done. 18 minutes.